Welcome to AIQA Engineer Roadmap 2026. I'm genuinely excited that you're here. My name is Santosh Ukade, and I've spent over 20 years in the trenches of enterprise QA as test automation, architecture, and consultant in Australia, from the trading floors of NAB, OFX, NBN, AGL, and ANZ Banking to government platforms at the federal government, Australian Department of Health, to energy markets at AEMO. If you have ever wondered whether AI is going to replace your job as a QA engineer, this presentation will guide you through the transition from manual to artificial intelligence driven quality assurance, equipping you with the skills needed for future success. Let's explore why this transformation is crucial right now. The data speaks for itself. QA professionals leveraging AI will outpace those who don't. It's that straightforward. QA engineering roles are growing 17% faster than development roles. Critical thinking has taken the lead as the top QA skill, with 60% of organizations already incorporating AI and machine learning into their testing processes. By the end of 2026, 40% of enterprise applications will include task specific AI agents, necessitating entirely new testing expertise. Most notably, AI QA job postings surged by 163% year over year from 2025 to 2026. The market isn't just expanding, it's booming.
Where does a QA engineer start with AI? This is the question on everyone's mind. The landscape is vast and constantly evolving, with new tools, frameworks, and methodologies emerging every day. Let's break down the journey into manageable steps.
Today, we'll explore five critical areas. First, understanding the AI QA paradigm shift from traditional software testing. Second, diving inside the AI brain to understand how language models work. Third, learning how we give AI better memory through RAG. Fourth, exploring the rise of AI agents that can take action. And fifth, understanding MCP, the universal connector for AI systems. Let's begin with the fundamental paradigm shift in QA. Traditional software testing is like checking a well oiled machine. Input goes in, predictable output comes out. But AI systems are fundamentally different. They are probabilistic, non deterministic, and can produce different outputs for the same input. This complexity requires an entirely new approach to quality assurance. The 2026 AI ecosystem is massive and deeply interconnected. From foundation models like GPT and Claude to RAG systems, AI agents, testing frameworks, and observability tools, everything works together. As a QA engineer, you need to understand how these components interact and where quality checks fit into each layer. The new QA goal isn't just about finding bugs in code. It's about protecting the AI brain itself, validating data quality, ensuring model accuracy, monitoring system performance, and safeguarding against harmful outputs. Your role expands from code tester to AI guardian. Now, let's go inside the AI brain to understand how these systems actually work. When you send text to an AI, it goes through four key stages. First, tokenization breaks your text into pieces called tokens. Second, embeddings convert these tokens into numerical vectors that capture meaning. Third, transformers process the context and relationships between words using complex attention mechanisms. Finally, the decode stage predicts the next token probabilities to generate responses word by word. Embeddings are the secret sauce that makes AI understand language. An embedding is a dense numerical vector that captures the semantic meaning of text so computers can understand it. Words with similar meanings end up close together in this multi-dimensional space. This is how AI understands that king and queen are related, even though they are spelled completely differently. Traditional keyword search looks for exact matches. If you search for sunny day, it won't find bright afternoon. But semantic search using embeddings understands meaning. It knows that sunny, bright, and warm are related concepts. This is crucial for QA because you need to test whether the AI truly understands user intent, not just matches keywords. Next, let's explore how we give AI better memory. RAG stands for Retrieval-Augmented Generation. It's a technique that lets AI retrieve external facts from databases or documents before answering your question. Instead of relying solely on what it learned during training, the AI can look up current specific information to provide more accurate responses. RAG grounds AI answers in real facts, dramatically reducing hallucinations. A traditional LLM might confidently give you wrong information, but a RAG system first searches through your documents, knowledge bases, or databases, retrieves relevant information, and then uses that context to generate an accurate answer. This is essential for enterprise applications where accuracy matters. The RAG process works like this: you have your knowledge base, documents, databases, APIs. When a question comes in, the system retrieves relevant information, validates it, feeds it to the AI brain, which then generates a response. As a QA engineer, you need to test each step. Is the right information being retrieved? Is it being properly validated? Is the AI using it correctly? Now we move from AI that thinks to AI that acts. An AI agent combines reasoning and tools to achieve goals. Unlike a chatbot that just responds, an agent can plan, remember past interactions, use external tools like APIs or browsers, execute actions, and learn from results. Examples include AI that can automate browser tasks, write and test code, or perform complex multi-step workflows. This is where QA becomes critical. These agents are taking real actions in real systems. An agent workflow is a continuous loop. First, it receives a task or goal. Then, it reasons through the steps needed. It selects and uses appropriate tools, maybe calling an API, querying a database, or clicking a button. It evaluates whether the results meet the goal. If not, it loops back and tries again. If yes, it responds with the final answer. Each of these stages needs validation. Validating agents is complex. You need to ensure they are pursuing the right goals, using tools correctly, handling errors gracefully, and not causing harm. An agent might get stuck in loops, use tools in unexpected ways, or achieve goals through unintended methods. Your testing must cover not just the output but the entire decision making process and tool usage. Finally, let's talk about the Universal Connector. MCP, or Model Context Protocol, acts as the USB-C for AI integrations. Just like USB-C standardized how devices connect, MCP standardizes how AI models connect to data sources, tools, and services. Instead of building custom integrations for every database or API, you use MCP servers. For QA, this means standardized testing approaches, consistent security validation, and easier monitoring of AI connections to external systems. MCP provides a secure, controlled way for AI brains to plug into your data and tools. The protocol ensures proper authentication, authorization, and data handling. As a QA engineer, you validate that these connections are secure, that data is properly protected, and that the AI only accesses what it should. The future of QA is here, and it's exciting. AI systems are transforming how we build software, and quality assurance professionals are at the forefront of ensuring these systems are safe, reliable, and beneficial. From understanding embeddings and RAG to validating agents and securing MCP connections, your role has never been more critical. Are you ready to validate the future? The roadmap is clear, the tools are available, the time is now. Thank you for watching.